Now let's go for it. Okay.
So the more discrete, let's talk about discrete. Discrete means you can only count them one at a time, right? Like the number of students in the class, that would be discrete variable, right? There's only one, there's only two, there's only three. Continuous variable would be like height of a person, right? It's 6.8 inches, you can make that into like very, very fine tune, right? 6.83, 6.8327 inches, right? So that is a continuous variable. So 4 points in chapter 4, again, just type of discrete variable, just things we can count one at a time. So first things first, something called a geometric distribution. There's two different distributions here. Geometric distribution. First things first, it has to be a discrete distribution with countable things. And then, of course, it has to satisfy these properties right here. So here's what we do. The trial is repeated until success is made. So you keep on doing it until boom, now you're successful. The trial repeated are independent of each other. We know what that means, right? It's the same. They don't have any effect. One does not have effect onto the other. The probability of success is constant at each and every single trial. And then finally, the X represents the number of trial. The first success occurs. Again, just a different way, because in statistics, you can do stats different ways here. Or could this be manufacturing is probably the one that comes to mind. Instead of testing 5,000 units right before you ship them out to see how many defective pieces there are, you say to yourself, hey, if there's only, we have about 3% that's defective, then we should find the defective piece in like the 70th one we test with it, as opposed to putting out 500. So just a slightly more expedient way of doing it. Okay, so what are we at? Here it is. So the probability of the first one that will occur, here's our formula. So if it is a geometric distribution, our formula is P times QX minus not show. That is the case. It covers up the Pearson thing. See, we're writing like a number 3 for the most part. Longer here. 2, 3, 3 more people, 2 more people. Go for it. The other one we're going to do, we're going to build a distribution called the decided distribution. So it's the geometric distribution. Just so we know. So here it is. Has to be discrete. Trials are repeated until successful. All trials are dependent. It's constant. I was thinking, another example I was thinking about is like, say you repeat a math class or another kind of class, right? Until it's successful. Trials repeated until success, yes, because eventually you pass the class, right? Repeated trials are independent, yes, just because you fail one doesn't mean anything towards the other one, right? Probability of success is constant. That one's probably the one that's actually more needed, right? Because once you know the content, you're probably more likely to pass, right? So your probability p-value has been changed the next time you take the class. That. But anyways, let's go with it here. One example, we're going to try to put this in. No problem here. Don't need to write down all the information. That's fine. You can just put it as example 1. That's fine. So a study found that smartphones made by a certain manufacturer had a failure rate of 43%. That is pretty bad. Hopefully the failure rate is more like 4.2%, not 43%. So 4 smartphones made by this manufacturer are selected at random on the assembly line. Find the probability that the 4th smartphone is the first one to have failed. So it's the 4th one. So the question is that true? Probability of that. Lockwood Technology Group. It says it's a full-on source. I'm not sure if this is really good. Everybody remember when? Let's see, when the Note, Galaxy Note 7, had some battery issues with it. It started just. You remember that? Yeah, see that. And it was battery would just heat up all of a sudden out of nowhere within the first 6 months or so. Second month, some people got a 3rd or 4th month. And then what they did is they scrapped it. They did not even make a Note 8. They just made a Note 9 at that to compete with the iPhone 9. That was fun. Okay, so let's go for it. First things first, you guys talk to me. Is this a geometric distribution? So let's check number 1 and see if that's true. Is the trial repeated until successful? Absolutely. Not the bets, we're good. Are they independent of each other, right? The first phone and the second phone, are they independent? Absolutely, right? There's no connection of the phones to each other. Is the probability of success constant? Yes. The probability of success is the fact of a failure rate of 43%. So that's going to be constant for each phone. Single line chain. Cool. Okay, let's go with it here. So we have our formula. Only right over here. It's P, which is what we want, and Q is the complement. So in this case, because we're talking about failure rates, our success is actually the failure of the phone. We're good. And so let's go with it. The next one, I can't give you the whole information. So P value. P is 0.43. Good. Got 2. Let's see, Q value. Anybody tell me what the Q value is? If the P value is 0.43, what's my Q value? 57%, right? Or 0.57. That's what we have for Q. And the other one is, what's X here? What's 4, absolutely. So we want that fourth phone. We want it to be failure, 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 and then success. That's what we want. F, 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 S. All right, let's plug into this formula. All yours, guys. Try it yourself on your calculator or phone. So this guy is 0.43. This guy is 0.57. And this guy's going to be x minus 1. So in our case, that one would be 4 minus 1 might be a 3 for us, right? Okay, go for it. And I'll just tell you the answer kind of has an 8 inside it. 0.08 something or other. So just try yourself. Go for it. Okay, or 0.0796 something or other. We're correct here. Nice. Okay. I have a person that actually even put 4 minus 1 in the exponent right here. They put 4 minus 1, and it still worked just fine. Okay. That's good. Okay. So 0.43. 0.57, and then 4 minus 1. If you want to take it down to 3, that's easy enough for us to do in our heads right there. So if you can punch that into your calculator, and 0.0796 something or other, go up to a 0.080. So about 8%. 8% chance of this guy having that. So what tends to happen in manufacturing is they'll do this here. They'll do these trials with the cell phone, and let's say probability-wise, the probability of the fourth phone being bad goes down further and further. So we're like down to like 1%. So at that point they say, hey, we don't have a 43% failure rate according to the statistics, and we only have a 26% failure rate, right? So these get to prove the fact that a failure rate is going down. Let's see. I remember, was it T-Mobile? I think T-Mobile, one of those advertising employees, not employees, I shouldn't say that. About maybe 10 years ago was dropped calls. You guys remember? You guys ever had a phone that had those drop calls all the time? Before you're so super awesome. Okay, but T-Mobile's advertisement was, we have the least dropped calls in the industry. So that's what they were sort of trying to get at. Okay. Let's do this real quickly here on your, let's go to the calculator. Get something. So you guys did it by formula right now, right? Let me try this. I think. This one's not that bad of a formula, so let's try it, right? Find it real quick. Yeah. Okay. So on your calculator, you're gonna find some fun statistics menus here. You ready? So this guy that says VARS is with variables, but we want variables. We want this little guy called distrib. Stands for distributions. Cool little stat button. So we'll have a TIE 4 or 83. Let's go to second and go to here. You good there? Cool. And then go down to the normal distribution. And one is combination, one's probability. So we want probabilities. So let's keep on going down. This is a T distribution. This is chi-square distribution. That's binomial distribution. Yeah. Oh, look at that. Poseidon distribution. I wonder if we're going to see that today. But we're going to go down to this one here. You want the one with the P. So that's probability. Okay. Everybody that's there that wants to be there. We're good. Anybody that's not there that wants to be there. So it's interesting too, because once once we do the 43%, right, we automatically move to 57, right? Because it's always a subtract from 100, right? So that's nothing to input. So how does this work? Let's jam with it here. So select geometry PDF, enter. And so what we're going to enter here is our 0.3, that's our percent, which we're looking for, is that right? Yes, we're looking for failure. That's right. We're going to put a comma here, comma, this is your comma right over here. Went up to the next data point, and I forgot which phone was it that we wanted to. Fourth, I think it was the fourth one. Okay, fourth one. So number 4 is on that side. Click, close off the parenthesis. Click enter. Let's see what happens. We love it. Okay, we're good. So there is 84. This pops up a different menu. Oh, gotcha. Okay, 84 pops a different menu. Interesting. Okay. Real quick, everybody got that number that was trying to get that number. Reason if you did not get that number, we'll come and help you just real quick. They're real good. Okay, guys, just one. I figured just one problem each. That's all we need to do on these guys here. So let's jam back to our problem here. Now we have the next one. Poseidon. Not Poseidon. That's a Greek god. That's a little different. Greek waterfall. Greek god of water. Okay, Poseidon distribution here. Lots of writing. Sorry, guys. Lots of writing for you guys. So these are the conditions we have to meet, and then we'll get the formula on the next page. As you guys are writing stuff down, go for it here. So discrete probability distribution, yes. Satisfies this. The experiment consists of counting the number of times an event X occurs in an interval. Yeah. The interval can be an interval of time, area, or volume. That's okay. Same in every event. Most people go to number 2 or number 3. Here, just a bit. Right, this is a good time to talk about it. Something about printing out the notes for 4-3, stuff like that. My little quick study here. So as I walked around the room, I noticed one person printed out the notes for the class. That's fine. I want to know. So real quick here, maybe the first question for everybody is, raise your hand if you wanted to print out the notes, you just forgot to print the notes. That's what I want. 1, 2, 3. Okay, 5. Okay. Then I have a question for yourself. 6 to a page or 4 to a page? That's it. 4 to a page or 2 per page? 4. 4 was better. Orientation was easier, I guess, right?
Because it has the definition and the concept.
Oh, gotcha. Okay, so you have more content to a page as opposed to everything sort of further apart. Okay, thank you. Just the other one that participated in our study. So for chapter 5, when we get in there, I'll print out 4 to a slide. Okay, unless you guys want to say, Mr. I do want to do 2 to this slide. I'll do it too. But my default is going to be 4 per page. Okay, guys, all done with the writing. Raise your hand if you have not done with the writing yet. Cool. Okay, hold on. Let's go with it here. So discrete probability, yes, that means something is countable, right? So here's how this works. Experiment consists of counting the number of times something occurs in a certain interval. So time is probably the easiest one, right? Sort of street corner, maybe in town. Time interval, how many accidents happen in that street corner for the next month? Good. And then say, is it actually a dangerous intersection or not? Should we have standards? I don't know, you guys talk to me. Should we have standards for the US to say, hey, let's label street corners as dangerous or not based upon how many accidents happen on that intersection? Yeah, sure. Should we have a list of most dangerous street corners in America based upon how many accidents happen on the street corner per month? Yeah. Kind of useful. Yeah. There's if you look up the most dangerous roads, there's that one. There's like 5 most dangerous roads where accidents happen all the time. There's one road in Philadelphia that's goes. It's there's a house in the corner. There's nothing there. It's always wet and slippery, and there's like literally an accident going right next to that house for like years and years. Yeah, people still want to live there. That's fine. Okay, so that's a time interval. Area would be like weed companies, right? They plant weeds on purpose. They spray, and then they're finding, okay, in this half acre, after spraying, how many weeds are still there, right? So, and then test the efficiency of the weed killer at that time. Okay, volume. I'm still thinking about volume here. But yeah, I'm gonna think of volume more. Okay, second one is this right here. So instead of getting to the first success, that's what the geometric distribution is all about. This one is you already have your space that you're looking at. Okay, probability of event occurring is the same in each interval. Sure, that's fine. And then the number of occurrences in one interval is independent of the other versus the other. So you can't connect those 2 intervals together somehow. So if you're going to do the weed spraying on that half acre, you better scrape all that down, right? Plant some more weeds the exact same way you planted them before, because you want them to be exactly independent. So you can't say like, oh, I'm going to throw some more down. That's not good. Okay. Finally, guys, we're at the formula. Here it is. Okay, one more. The probability of the exactly x occurs in an interval is there's your. So it's mu. Remember, mu is the average. oh, we've got this new letter called E. Have you ever seen E in math classes before? E is a number, it's kind of like pi. Pi is 3 point, or about 3.14. E is about 2.718. So approximately that number. As soon as you guys start writing, as soon as you guys finish the formula, we'll try to find it on our calculator. Okay, and on the bottom, hey, there's our factorial thing again right there. So we'll work with this in just a bit. The accidents at a certain intersection, that's exactly the example in our textbook. Promise, we didn't even look ahead. Just we often be vibing on the same thing. Okay, so mu is going to be the average or the mean of whatever is happening. That's the average there. X is the number of occurrences that should happen. Then it's e to the negative mu. Oh, that's funky. X factorial. There's more letters in that thing. All right, we're good to go. Jim, let's go with an example here. So let's see if we can put this in. So the mean number of accidents per month at a certain intersection is 3. Not dangerous, not dangerous. I don't know. What's the probability that in a given month we're going to have 4 accidents will occur at this intersection? So one more, let's go ahead, one more than normal is going to happen. Okay, guys, talk to me here. Identify the, let's identify the mu. What's my mu average? 3, right? And then my x value. 4, that's all I need. I just need those 2 things right there. Okay. So then let's go with formula. I'm going to write P of 4. Probably the 4 things that are happening. Let's see. Formula. Here we go. So the first, my mu is mu is average. Let's write that over here. So the 2 things I just need to know for my information is 3 and 4. The rest is part of my formula. Okay. 3 goes in, it's 3 to the 4th. Bounce back to that one. Then it's E to the power of a negative 3 over 4 factorial. Okay, a little more complicated formula. So we're going to do it together. And if you can do it ahead of me, that's fine. Perfect. Do that, please. So into our calculators. No, that's too fast. 3 to the 4th power times E, let's find the E button. E button is like right over here, good? It's what is called LN button. So it's called the natural log button, and then E is the exponent. And it's a -3. Your negative sign is right here. This guy is a subtraction symbol. That's an operation in mathematics. This guy is a negation, right? Totally two different totally things. Look the same. Okay, I'm gonna close that off. And then divide by 4. Anybody found the factorial button on your calculator yet? Under where? Under math. Let's go for it. Under math. Under probability? Yes, it's number 4. Okay. Ding, ding. So under math, scroll over to probability, right under the NCR value. Click enter. And is that about right?
Yeah.
All right, did it by formula. That's cool. That's awesome. All right, the other way to do it. We should go both ways, right? Let's go with second. Oh, remember this is the distribution stuff, right? This is the distribution thingy. But so how about second distribution? And let's go down to something called procyon. And you want the p-value. It's the probability instead of the combination. Procyon probability distribution function. That's kind of what it means. Okay, let's click on here. All right, and just like we did, there's 2 numbers we need to put in. First one is your mu button. Second one is your x value. And the only thing that students get mixed up on right over here is they'll switch those 2 around, right? Or like, oh, come on, I want to put it. So it always asks for that, and that has to be very specific order. We did, it's like the previous one, we put in 4.3 first, 0.43. Probability goes first for that one. Afterwards comes the success of which trial. And boom, Tristan, did you have that?
I don't have the fancy.
Yeah, as long as you got 0.16803, blah, 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 we are good. Okay, cool. And one more. Yeah. And. Yep, sure, absolutely. You guys, let me walk around real quick here. Second. Please. Okay. Oh, yeah, I got a fancy. That is number 3. Yeah, next up. Sweet. That was so simple. All right. Giselle, how did you do? Hey, you 4. How did you guys do? Okay, sweet. Just want to make sure. Okay, there it is. Da, da, da. Okay, one more thing to do is by table. Oh man, we're gonna do it the non-calculator way. And so the first question comes out, Mr. Ng, are you ever gonna make us do something by table? Yes, eventually numbers like in chapter 6 and 7 will do tables, but for now, we can use the calculator to do that because there's special tables there that we have to think about. Okay, so we're going to use this by table, and the table that we want is table 3 in your textbook. If you have the textbook with you, that's okay for now. So total low tech, here we go. Tables, so it's not all the way to the back, it's not this way. Not this side, because you know, if you open it completely, you start at table 4. That's the first table. And I think we're going to use this. It's in the back of the book. Okay, real quickly, just so you guys know. Chapter 4. Chapter 4, see chapter 4? Those are all the formulas that we need, right? So just so you know, formulas are all right. Not going to use that table. Close this guy up. Close it up. Chapter 6, then we'll open that. Okay, but as you flip like this, if you flip back like this, you'll get to, notice it's your A values, right? A, and the table number page? 811. Everyone at 811. That looks like this. It should say Poisson distribution right on top. Okay, pretty good. We're just going to look on the test. I will not require you to do it by table. Okay? This is just exercise. All right, so population count shows the average number of rabbits per acre living in the field is 3.6. You could table to find probably that 7 rabbits are found on 80 given acre. This is a pest control problem here. Okay, so what do we do? We find 6 along this way. So going down, down, down. So notice it has it says mu on top, right? Mu on top. We go down to, we need 3.6 to happen. So I think it's this last table down here. Right there. And then once we find 3.6, then we're going to scroll down to find 7. What is that 7 right there? And what is the answer there? 0.0425. Are we good? 0.0425. Everybody good there that had a book that found it? Okay, I'm going to give it to you guys the other way here. Can you guys do this one by calculator though? Once we found it by table, same problem. You guys do it by calculator again. See if you get the same answer that you did on the table. All right, I'll walk around and get some of the same exact formula that we just did before, right? And so if you do the exact same formula, exact same as you guys did before. Fine, make sure you guys get 0. Let me write on the board here. This is you're looking for that answer. 0.04. I think it's 0.0. Yeah, 0.0425. That's a little. All right, walk around and get those that need help. Walk around. Good. All right, exact answer, right? Oh, wait, what's this one? This first goes like way. Good, awesome. Yeah, oh, is it thinking? This is kind of basically someone if it is exact answer, it will exact answer. If it's not, then I'll float out as much as it possibly can. Okay, guys, real quick here, just wonder, interested, Andy, you 0.14. No, okay, so let's do this. I'll change it up. Class, let's go with right now. Let's do a 10-minute break. Those that have homework questions want to come back, go for it. Or just want to use it as study hall time, just kind of catch up on your homework. That's better, right? Or if you just say, I'm actually, I don't see your face today. Mr. Wise, my it's if you got, I'll see you guys on Tuesday. Again, on Tuesday, if you need the homework, I'll come. Otherwise, Thursday, you come in, you have your homework with you. Chapter 3, chapter 4, all in order, stay put together. I gotta stay with you. And we'll take an exam. Okay? Also, Tuesday, if you want to come just with study guide questions, because I want to make sure I protect the study guide well. So if there's something like totally not clear, like number 18, I have no clue that's coming from. It could be that I just didn't write the instructions well. So, two choices: take a break, come back, study all our homework questions, go into home. Choice to come on Tuesday if you like. Thursday, come and take the exam.
Oh, look at that.
Second test. Let's see. Second here. Yeah.
I'll get on set it up.
Yes, try that one, see if that one comes up. Okay. Yes, perfect. Yeah. So it's about that. Absolutely.